Hey everybody, we're obviously on the hour now. We're going to give about another minute for people to get the plugin installed and get actually operational here before we get started. But we are here. Sorry for the little mix-up last week in terms of the time being 30 minutes early. In the announcement, hopefully everybody saw the correction that we sent out. If you got here 30 minutes early thinking we'd be here, apologies. But we'll get started in just a second. Anyway, so what we usually do with these is make fun of each other for what we're drinking. So Larry, since you were just bragging about something or explaining how you survived registration.
That's right.
What are you drinking exactly already on a Thursday?
We were talking about how to get through registration without, just being angry at times. And so I recommend Iron Wolf. Iron Wolf whiskey. It's a whiskey with bold spirit and a Texas attitude. So if you just add your coffee,
bold spirit with a Texas attitude, or something like that, right?
That's right. That's right. That's about enough for your coffee, and so that's good. That'll work. So
we need to get Iron Wolf to sponsor BIM University.
It's just right. So that's that's the way we do it.
All right. Well, I as usual have Dr. Pepper and bubbly water with cranberry juice. I'm doubling today. So, Randy, anything interesting?
I'm just staying hydrated over here in New York. So got some Gatorade. We don't start drinking until 4 or 5.
Yeah, Gatorade. That's after a rough night. I do that too.
and Sylvia is also known as the Scanpire, so I assume he's drinking blood.
No, just after dark. I need to stick with water. As you know, if I just take a sip from a beer or anything with alcohol in it, I get dizzy right away. I don't have. I need to get more training.
Yeah, those big windows in his background, I'm pretty sure are virtual. He's not really allowed to be it was sunlight. That's it's green screen.
So. All right, let's get rolling, fellas. Thank you everybody who is on the call here, has joined us today. We're really looking forward to this. My personal opinion is that registration is actually probably the hardest step in the entire workflow, just in terms of technical skill. It's not the hardest step in terms of effort. That's actually probably generating models from the scan data, but just in terms of knowledge, learning curve, everything else, I find that getting an okay registration is pretty easy. Getting a good registration is really hard. Getting a really tight registration is like Herculean. Just requires tons and tons of training. So that's what we wanted to talk about today. So with that, let me hop into our next slide here. Do a little housekeeping. All participants are muted at this point, but please ask questions via the little question thing. So, I already see that Chris Tarzia is advocating for a raffle for that bottle of whiskey. Interesting.
If you put your address in the comments section, Kelly will send you a free bottle. I think that's how that works.
And John Mayer is asking for a Scan to BIM t-shirt, and if it's the John Mayer, the musician, then I'm pretty sure we'll get you one. As long as you promise to wear it and be a brand ambassador for Scan to BIM University. But yes, please ask questions during the chat. We will answer some of them on the fly, like that one, but most of them we'll save for Q&A at the end, which we will run an extra 30 minutes at the end for Q&A. We usually have lots and lots of Qs, and so the A's take some extra time. The webinar is being recorded, so if you need to drop off, if you get interrupted because there's a delivery at your door, which may happen to me midway through the call, that requires a signature, or anything like that, we are recording, and anyone who registers before, during, or after the webinar will get that link to the recording. So, send it to your friends, have them register, they'll get the recording, please. And yeah, that's that. So, without further ado, or jokes, let's introduce our wonderful panelists. Sylvie, do you want to say hello to the audience? Please don't bite them.
All right. Hello, everyone. My name is Sylvie. I'm a scan to BIM geek. Been doing this for, I'll say, 12 years now. And Kelly and I, we've been experimenting for many years with this technology and trying to improve the process. I'm currently running a small company that's focused on creating as-builts and providing support to architects called RC Monkeys.
Awesome. And Randy, tell us a little bit about yourself.
Yeah, thanks, Kelly. So my name is Randy Marks. I work for a company called Zealous. We operate in the United States, all over the place, scanning and producing as-built BIM models. You can see in my comments that I've been using Ferrocene for a long time. So it did put some stress on my life at a young age, but it is one of my favorite programs. So I'm really excited to just chat through some of this stuff today and be able to share some insight that we've learned over the years working in these platforms.
So Randy, you're zealous, whereas I'm overzealous.
But
okay. Larry, say hello again.
I'm Laser Larry Kleinkemper. Been scanning since like 2007. I'm a licensed architect who's been computer modeling buildings since the days of DOS. And yeah, I'm hoping that we have some fun today.
And I am Kelly Cohn. I am the host / moderator / bad pun or terrible joke advocate for the day. And yeah, let's just dive in. This is such a fun topic for me, which obviously means I'm also a geek. But registration, it just I spent way too much time doing it. So one of the things we wanted to start out with is talking a little bit about field registration versus office registration, because there are obviously advantages and disadvantages to each of them, and so we just wanted to kind of take a bit to talk about that before diving into the kind of general kind of fundamentals of registration. So Randy, I know you had kind of an interesting take on field registration. It was a little bit different. So why don't you tell us how you guys look at it at Zealous?
Yeah, so at Zealous, one of the things that we've found is with the new and consistently improving software that allows you to do field registration, we're still able to process it faster if we get the data off the scanner and get it back to the office as quickly as possible. So we don't do any in-field registration at this time. What we've found is that a lot of times you'll end up registering it and then having to either rework it or change it once it gets back to the office anyways. So at Zealous, we've leaned away from that process until kind of that technology catches up to it.
Gotcha. And Silvio, counterpoint, sir.
Yeah, I mean, I think it depends on the tool that you're using. Yeah, there are some tools that you're faster, just scanning and just moving fast through the building. But probably the most important thing is to ensure that your guys are doing a great job and they're efficient. Take a lot of notes. Print your floor plans and just mark where you started, where you ended. And that way, if the building is complicated, and know which scan connects to which scan. So in my opinion, that's a must if you don't do in-field registration. Have good field notes.
Mm-hmm.
Yeah, and Larry, you got a hot take on this?
Yeah, well, we do it a little different. We tried ZNF and we could never convince the tech to carry the scanner in the correct direction. And we've tried a number of different ones, although we think they're really cool. And once you get once you get used to it, you probably could get faster at it. But what we found the most efficient for us was just to take a high-powered laptop out to the field with us. And then after you've done about 40 scans, when you go to change the battery, you change the SD card. And we immediately get those scans copied to a laptop so that there's a duplicate. And then we start importing them, and before you get to your next battery change, you can usually start to see, you know, whether or not you got any issues.
Yeah. And so that's you know, kind of 3 different takes right there. You know, I think we talked about this a bit in our last ScandiBIM University class, which you can of course go to www.scandibimuniversity.com, and if you do that, you can you know, look at our old classes, get a link to download the video and all that stuff. So I do recommend that if you missed some of those, by all means. But you know, if not, you know, I'll do a quick rehash of that. I'd say the panelists last time they generally saw the advantage for in-field registration being that it kind of pre-located the scans roughly in the right place. So, you know, the only field registration, the only software I know that does allows you to do a full registration with, you know, additional cross-linking, full bundle adjust, all that kind of stuff in the field is the ZNF laser control software. Everybody else, it's really just a pre-registration. But the advantages that they kind of pointed out were that because all the scans are roughly located, it makes building up the registration map in the other software, building up the you know, the graph quickly a lot easier, because you don't start with all the scans kind of in one location and then have to get them in the right place to establish a link or go through and visually align every single one. You can kind of quickly build up a graph, hit go, let it find the match based off a pretty limited distance, and then take that to the next level. So, you know, I don't really know anybody that's actually in the field, you know, even using the laser control software for ZNF, that's really doing everything in the field. Most of them seem to be using it as a pre-registration tool as well. But I think that was the big takeaway when we talked last week was, you know, field registration, if you're doing it, just don't get confused and think that it's an actual registration. It's really just a pre-alignment. It's like you know, it gets you close. So.
And Kelly, if you like, I can quickly show 30 seconds how that looks, at least in one of the software.
Yeah, let's make you a presenter here. I'll pop that up. Attendees. No, I need. There we go. Staff. There you are, Sylvia. Make presenter. Yes. Yeah, that'd be awesome.
All right.
We always like live examples.
Let me know if you can see my screen.
Yes.
All right, perfect. So what I have in here is a very, very small registration, 3 levels and the exterior. And what you see here in the list, these are all the constraints created in the field. So as Kelly mentioned, it allows you to have that minimal number of constraints between the scans. So exterior 1 to 2. But as you can see, these are not aligned. So they were just imported into Cyclone and they're not aligned. The next step is to use this pre-alignment that was done in the field and let the registration software, the desktop software, to analyze exterior 1 to exterior 2, so on and so forth, and do that alignment and registration, proper registration in the software, and then you can optimize it. But this is how it looks like. It sets a minimum number of constraints that allows you to do that preliminary registration in the office, which is, it saves a lot of time. So that's it.
Sylvia, what happens if you if you click register, you click optimize?
So if I click register, because these are not aligned, it's going to start to optimize these constraints, right? So if I click register, it's going to go through, it's going to say, hey, wait, you have 99 constraints. It's going to go and align them, right? It's going to look at them, and then based on your settings, is going to go through up to 1,000 iterations to find the best alignment. So you see that you need to have that small area between the below the graph as small as possible to get the best result.
Yeah. Well, hey, when this actually finishes in the background, it'll be fun to come back and snap and look at it. And actually,
I already have a version finished.
Oh, well, then go to it.
All right, let me close this and open my navigator here.
Burying the lead over here, Silvio.
Yeah, so here
And
you
this,
have
by
this.
the way, for people watching, this is like a cyclone register that we're in, right?
So as you can see here, it went through the alignment. You know, it's not excellent, but because you can see these group errors, but it just went through the first alignment. I found a lot of overlapping points. And, you know, after this, you're gonna analyze it, visually analyze it, look at the results and start finding all your problems. But we can discuss about that during our QC process in more detail.
Absolutely. Can you quickly show the group result on the screen, the graphical?
Yes. So let's grab this one.
There you go. Stuff's
But,
already lined up.
Yeah, somewhat. I mean, look at this. Right.
Ish.
So that's not right. So that's why, you know, your first step, you know, things are, I mean, it looks like a building. So from this point on, you can start looking for visual misalignments, look at the results, and you know, visually inspect each alignment and re-optimize those constraints.
Yeah. All righty. Well, let me steal this back here. All right. And hopefully you guys can see my screen again. So jumping to our next topic, popular registration tools. So obviously there are a lot of registration tools out there. You know, Recap, Reconstructor, Scene, Cyclone, Laser Control, Collage. These are just a few. There are actually more. Probably the one that most people are familiar with would be something like Recap, because pretty much anybody using Autodesk software at least has to touch Recap at some point in the process. But the other kind of really popular ones are going to be Scene for people that are Faro-based laser scanners, Cyclone for people who are using Leica-based scanners. I completely forgot to type in Trimble software, probably because I can't remember the name of it off my top of my head all of a sudden.
RealWorks.
Thank you. Yes, RealWorks. So if you're using Trimble, the Trimble ecosystem, RealWorks would be in here. You know, generally people use the registration tool that comes with their laser scanner. There are some third-party ones like Reconstructor, made by Jixel. LFM had something for a while. I'm not sure like what ended up with that. Collage is TopCon, so if you have TopCon laser scanners, you'll have Collage. So yeah, usually though, most people use what comes with the hardware that they buy. I know on this call, we've got a bunch of different people using different mixes. So just real quick, I want to go through and kind of find out what everybody typically uses. So Larry, why don't you tell us your workflow first?
Yeah, sure. So we tried the different registration programs, and what we found for teaching the team was Recap ended up being the most cost effective. It has the fewest tools, but it does a decent cloud-to-cloud auto registration, and it had the lowest entry point for teaching the whole team, so that they, if there's a problem while they're modeling and they spot a misregistration, it's easy to fix. So we like Recap a lot, and tend to use it on a lot of our jobs.
Randy, what's y'all's ecosystem?
Yeah, so like you mentioned, based on the equipment that you're using, you typically you play in that arena, right? So we use both Faro and Leica scanners out in the field, and so we are pretty versed in both Faro Scene and Leica Cyclone registration. So like Cyclone, Sylvia was showing you, it's a little bit more complex, has a lot more options and tools. If you're skilled in it, you can do just about anything you want, but it's a little bit more complex than what like a recap would be, or even a Faro scene, right? And then Faro scene is one of our favorites just because you can a lot of times it does have those tools available to you, but you can also use a more easier form of the registration software, and a relatively new user can learn it quickly, and then to really develop and master the skills to understand the in-depth pieces of it, you can have that, right? So it's got an expansive capacity that it can get more interesting and more complex. So those are our two main platforms that we work in.
Gotcha. And I see Mr. Pat Carmichael has entered the building in Larry's background there. Hi, Pat.
Give a good wave real quick. Hey guys. Yeah.
Yeah, Sylvie, I know what you use, but go ahead and tell us your allegiance.
Yeah, so I'm using an array of scanners from Faro, ZenNF, and Leica. So I like the software that allows me to import all of that data seemingly, and the Leica products seem to be working very well with all the other tools. So I'm using Cyclone as well as Register 360 from Cyclone, which is a lighter version, more visual, very easy to learn compared to Cyclone. But for larger jobs and jobs that I know I might have registration issues, I'm gonna use Cyclone. Also, the advantage is if you start with Register 360 and you have a problem, you can always import that project into the Cyclone tool. It is more expensive to purchase Cyclone, a lot more. It's probably one of the most expensive tools that we have listed here. Yeah, and if you want to slice, for instance, if you want to cut a slice through your point cloud, you need another module. You can, I mean, yeah, I mean, you buy the register module and then you realize you don't have the tool to do your proper QC. So then you spend another $1,000 on another module just to cut slices through your point cloud. So those are some of the disadvantages, but you can fix almost any registration with Cyclone. So if you did a decent job in the field, obviously.
And you know, at ClearEdge, we obviously work with pretty much everybody's scanners because we make software that works with data from all these tools. So you know, we do a fair amount of stuff with ZNF and work in laser control. Do a fair amount of stuff with Jexcel and their Reconstructor product. One of my favorite things about that is it's a little like Cyclone in terms of just having all sorts of weird little bells and whistles that you can do stuff with. But it works really well with both mobile and terrestrial data because they actually make a mobile scanner, but they do a lot of integration stuff with terrestrial scan. So it's a really neat tool if you're working with mobile and terrestrial data because there's some specific stuff for that kind of workflow, which is really cool.
One more thing, Kelly, that I want to add, sorry for interrupting, is the one thing that Cyclone supports that I like is the hotkeys. So if you're into optimizing your workflow to the max and trying to squeeze as much as you can from the tool, I mean, you don't have to touch your ribbon. You can work with hotkeys doing almost everything.
So as the people listening are figuring out about Sylvie can effectively do the work of 3 people because he can have 2 keyboards on 2 computers and he's entering hotkeys with both hands on different computers. Like he's just, yeah, like don't sell Sylvie efficiency tools because he's already eked everything out of every tool that he has. It's actually kind of crazy. Randy, one of your fun facts was that you went bald early because of Scene. So why don't you tell us about this meme that you found in your company's office?
Yeah, so I was walking downstairs one day when we call it the pit, the registration pit is where all of the data gets processed. And so I walked down there and these guys, as you know, if anyone who's registered has seen a progress bar, you get some free time, right? And so they had printed out a bunch of memes and this was my personal favorite. From anyone who's seen The Notebook, personally, I haven't, right? No, I don't watch those kind of movies, but this is a pretty funny scene from that our guys superimpose the Scene symbol, and occasionally the Cyclone symbol will go up on there as well as really any other registration software. So just a fun one I wanted to share with the group.
Yeah, and this is a good segue to talk about computer resources, because we've gotten that question from a lot of people in the past, and actually I think I see somebody asking that question already in our feed today, in terms of, you know, what kind of a computer should you have for this? And so, you know, the unfortunate answer is that different tools like different things. So Randy, what would you say Scene needs the most?
RAM. Lots and lots of RAM. Yeah, so, and that's one of the reasons why there's the frustration with it as well, right? So you could get in there, get everything running, and if you don't have the RAM to load the scans and do the registration, especially when you're doing cloud to cloud, there's crashes, and Scene doesn't have an autosave. So one of our biggest rules is save early, save often, and usually our teams do it every 5 minutes or so, right? Just to make sure that they don't fall back too far behind. But when it does crash, they've got a meme for that too. So.
Sylvia, what and I know actually Register 360 and Cyclone Register like different things. What do the Leica products like?
A fast hard drive, probably that's one of the primary things. Solid state drive would be recommended because you're using a lot of space for creating temporary files. A balanced processor, because sometimes using it's multi-threaded depending on what you're doing. Sometimes it's just using one core. So having something that is balanced, around 5 gigahertz overclocked, I think that would be ideal. And obviously about between 32 and 128 gigs of RAM, but with 32 should be sufficient. I'm running Cyclone on 3 machines, and one of them is probably 4 years old, and it handles Cyclone pretty well. And you can also adjust the settings based on your computer. You can load less points. You can adjust how many resources are used for importing, for registration. So RAM, sometimes the graphics card it would be nice to have a nice graphic card, but it does the work with a lower performing card.
Yeah. And for Larry, I should put recap here instead of Cyclone Register 360. But yeah, Larry, quickly on the hardware stuff for recap. What do you think is most important?
Yeah, I think Sylvia covered it really well. I would tell people, if you're starting out and you ran down to Best Buy and bought the best laptop they had, if you have under 16 gigs of RAM, you're going to experience crashes. At 16, it starts to get somewhat stable. At 24 gigs, it gets more stable, but you're still going to experience crashes. At 32 gigs, that's really the threshold to where things will you'll almost eliminate most crashes. And so that's the biggest factor I can mention. Anything else, it's like the faster the hard drive you have, the better. The faster the processors you have, the better. But the RAM is really the part that's going to frustrate you the most. If you don't have enough of that, you're going to experience a lot of crashes.
And it's one of those funny things, like, because Cyclone is one of the oldest pieces of software, it was written back when RAM was not available in gobs and gobs, which is why they write all the temporary files. So I remember when we bought a super fast, overclocked, crazy computer that cost like $10,000, 10 years ago to do our registration on, or 8 years ago. We were very shocked that the performance in Cyclone did not increase very much. We were very upset about it. But then we happened to have ordered a big RAID drive and RAID array because we were going to use that for backup. But of course, that gets you a lot more throughput, a lot more bandwidth. And what we discovered was that actually, increased our speeds in Cyclone by like 3 to 4x. So we could have just gotten a crappy computer and bought a really expensive hard drive and hard drive array and gotten the better performance. But yeah, most of the newer tools, including Register 360, they're much more capable of taking advantage of multiprocessor. They're much more hungry for RAM. My spec recommendation for people doing a lot of this stuff is 128 gigs of RAM, because particularly if you're using Scene, because that just eats RAM alive, eats it for lunch. So cool beans. I think.
Ellie, quick question for Larry and Randy. Have you guys tried to work over the network? The project to be saved on a network. Let's assume you have a 10 gig speed for that network. Does Recap or Scene, do they work over network?
Yeah, I mean, you'll see some amount of lag if there's a bunch of people on working, but for the most part, yes, you can. We save all of our stuff to a server, and but we've got a decent local network set up. Now, if you don't have that situation, or you've got a lot of people in your office and a bunch of millennials that like to stream stuff all day, then you might want to work locally. So.
Yeah, and I would add that on our side, our team works almost exclusively locally, but what we've done to allow for our team to work remote during the last year is we've set up all of the desktops are set up in the office, lined up next to each other, and we've set our team up remotely, working on a remote desktop. So they have access to 2 screens, and they're working off of those desktops in the office, but they're all over the country, really able to log in and work on that. And we've seen 0 lag issues with that, specifically because they are tied into our office network, right? So they're all working together.
Yeah. Yeah, and we had a couple questions come in, because I know, Larry, you've got an opinion on this, and Sylvia, you mentioned it earlier. Where is that threshold for when you switch from Register 360 to Cyclone Register? Like what size, and Larry, in your case, Recap to Cyclone, because I know you said on certain size projects you'll make that jump too. Just how many scans roughly?
Yeah, so if we're doing a large industrial project where there's a couple thousand scans, that's where we're more likely to switch over to Cyclone and Leica scanning. So it's the higher the precision, the more scans that we're going to have to deal with, then we're more likely to cross that threshold.
Sylvia, what's that number for you?
Yeah, it's probably 500 scans, 400 to 500 scans. I would switch to Cyclone. Also, sometimes it depends on the data that's being registered. I do get data from clients captured with a BLK 360, and the results that I get with Register 360 is completely different than what I get with Cyclone. So there were some registration issues that I could not solve. The algorithm would just render the same results over and over, and then you switch to Cyclone, re-optimize those constraints, and you get different results. So that's also a factor that plays into choosing the right tool.
Yeah, I think we've seen the same thing out of Register 360. Is if you're struggling with it, it's once you start seeing issues, it's a lot easier to fix in Cyclone than inside of Register 360. So.
Yeah. And do you guys, Randy, do you guys have a threshold jumping from Scene to Cyclone, or from something else to Cyclone, or is it really just, if it's a Faro scanner, it's Scene, if it's a Leica scanner, it's Cyclone?
Yeah, there's very, very few times that we go from Scene to Cyclone. We've done over 1,500 scans inside of Scene and had been able to put them all together. So that is the only time that we would do that. Is Cyclone does have a better cloud-to-cloud platform from what I've seen. And so if we're really struggling to get constraints from Faro, accurate constraints, then we can switch over and do that. But we primarily just stick with the software that the scans came from.
Gotcha. All righty. Awesome. Thank you for those answers. Let's jump on to primary registration methodologies, kind of meat and potato stuff. So as we've kind of got three primary methodologies: survey control, targets, and cloud to cloud. And targets are actually kind of a little bit like survey control, but with the absence of maybe shooting them in ahead of time, but you're effectively using a kind of point-based arrangement to get your stuff registered. But with survey control, typically, you're having somebody go in and shoot those things in ahead of time. So there's a known coordinate before you scan. Targets, you're usually acquiring the coordinates from the scans and matching. So a little bit different methodology in terms of how the coordinates are established, right? Cloud to cloud is obviously making a comparison between the two different scans, looking for overlap and fitting, basically trying to find different things to figure out how they relate to each other. And then there's some other kind of more esoteric methods that, some of the more advanced software tools have, like Cyclone or Scene or, Reconstructor or things like that, where you can actually recognize geometry or find planes or find intersections of planes in the software to establish a point, and then use that point as a target to kind of line things up or as a constraint. But I thought it'd be good for us to kind of run through these at least a high level to kind of talk about them and discuss why they're, various things about them are important, why you might use them. We talked about actually establishing survey control in the prior class, so we aren't going to kind of dive into the field practices behind these things so much. But in terms of the actual in-office practice of using them, there you go. So Larry, why don't you talk a little bit about survey control, because I know you guys are pretty thorough about getting that established on jobs, and we've talked about it before. So I'll let you go first.
I think that's one of the biggest newbie mistakes, is the idea that they see cloud to cloud and auto registration and they're like, I don't need targets. Oh, but you do. So it's do we always use a total station with them? Not necessarily, but on larger jobs we absolutely do. And if you want to tighten up the registration at all at the end, and you don't have targets, you can't really. So it's targets are how you constrain things to make sure that you end up with something that's somewhat accurate. On our fourth job back in 2007, we learned the hard way as we were just starting to understand this stuff. And I can look back and go, okay, the guy who was teaching us and had the scanner, he was 99 to 99.5% accurate. Unfortunately, over a 400-foot building, that means an error of 2 to 4 feet, which really did not fly for the client. So, that's how we ended up learning that, hey, we might need to add an extra instrument, and we might need to add targets for control.
Yeah. Well, and as we saw on Silviu's screen earlier, right, he ran those constraints and there were what looked like small errors. If you recall, like some of the constraints had like a 0.1 meter error. So you think, oh, that must be really close. But then you look at the results and you're like, there's like a whole extra 12 feet of building missing, right?
Yep.
That's not 0.1 meter, that's like 7 meters, right? And this is, this is kind of one of the fundamental limitations of cloud to cloud, right? So you mentioned targets. I tossed some targets types up here on the screen. When you're doing survey control, you can also set up a rod with a a prism or a target on top of things that you mark on the ground, nails that you pound in, things you spray paint. One of my other laser scanning buddies actually has a template and just carries the template in black spray paint, and he actually just like puts the template up and sprays back black spray paint for a permanent target on surfaces that are going to get covered up. So you can use almost anything, but having these targets, it gives you something that gives you a much more understandable error metric. Because the target will give you things like there's a 7 meter discrepancy between this target and the measurement of this target and this other scan, right? But things, like long corridors, right? Like these are nightmares for cloud to cloud registration. Or the long facade of a building that has repeating, facade elements. Like anytime you have repetition, cloud to cloud falls apart. My other favorite is round rooms. I was doing some scanning for Built, the people that put on the Built conferences. Actually, DBEI is the organization, and they wanted to scan their facility, and they picked this building where all the rooms were round, and the building was round, and they tried to scan it without targets. They went and did all the scanning and sent me the files, and I have this round building with no targets, and I'm like, I can't register this. It's round.
I mean, we don't use as much as we used to. 10 years ago, we had to have 5 targets behind, and 5 targets ahead of the scanner. And in order to tie one scan to another, these days, we're trying to get, targets up on and there's certain things that you're looking for. Long corridors, staircases, these are places where the cloud to cloud registration is going to fail, and on a regular basis. Or if it's got bays that are identical, that everywhere you look it looks the same, and if I put a blindfold on you and moved you around the room and took it off, you'd immediately be lost. Those are the situations where you need to get some targets up, and it'll help make sure that the registration isn't getting mixed matched of locations.
Kelly, I'd like to add something, if I may. So about, I think 4 or 5 years ago, we were at Beck, and I was talking with a Leica rep, and he was asking me, how do you guys register your projects? And I said, mostly targets. We had some cloud to cloud constraints wherever we feel like is needed. And then they asked me, have you tried the other way around, to start with your cloud to cloud and then add targets wherever you need them? And I said, no, that doesn't work. And right about that time, they changed the algorithm of the cloud to cloud for the both. At that point, it was just Cyclone. And I was surprised, because we would spend so much time hanging targets up, and we would just base our registration on those targets. But now I think things got much better, right? Most of the constraints are cloud to cloud. Maybe 10 to 20% are targets. As Larry said, in those hard to get conditions, staircases, corridors, round rooms. Also, when you get out of the buildings, when you try to tie exterior to interiors, that's also a good time to use some targets. And it definitely changed the way you handle a registration. And if you have similar bays, the field registrations definitely help you to pre-position your scans to eliminate some of those misalignments with the auto registration algorithms. And if you want, Kelly, I can quickly show you a picture, or just a live view of how you add a few targets when you transfer from an interior space to an exterior space, where cloud to cloud would definitely fail.
Yeah, absolutely. You are now the presenter, sir. All
righty. So this is just a small lobby here, and you can see this is the exact same building that I showed you earlier. It's just a facade, nothing on the other side that I can use for cloud to cloud. These are not planar surfaces, so probably the registration would have failed. So I just added 3. Sometimes you can add them on the floor. You don't need to add them, on the walls. So I just add 3 different targets that I also captured in the previous 2 locations. So if the cloud to cloud fails, I can rely on these 3 to make sure that when I tie the interior space to the exterior space, everything will come in the right spot. You can add more if you want, but yeah, you need a minimum of 3 to constrain your registration on all 3 6 degrees of freedom.
Hey, can we talk about just briefly target placement as well, because you did.
Yeah.
So really what you're looking for is XYZ surfaces. Okay.
Yeah, if you
so
put all of them in the same plane, they're not going to work.
exactly. If you know, one of the rookie mistakes that anybody, you take them out at the first time and say, just throw up some targets for me. The first thing they do is they start taping them to the wall all at the same eye height, you know, as opposed to what you want is really good, you know, triangulated geometry. And so you want a low, medium, and high. And I love putting them on the floor. I agree with Sylvia. The idea that, you know, you put it in the middle between two scans and it gives you a really good point that you can pick on.
Yeah.
Yeah. You can also then set up with some scanners, you can set up over the target with a plumb laser and then basically use that like a control point, which is really nice as well. And a great way to kind of check your overall errors. And actually, Scott Reed in the last, because we talked a lot about targets in the last webinar and placement and practices there. My favorite pro tip out of that, Scott has targets that are printed on double side. And very carefully printed double side so that the target center is actually on the same place on the paper. And he will hang those on glass windows, because the problem with shooting targets through glass is that glass refracts the light. And if there's any kind of film like low E coating or something like that, it changes the refraction, blah, blah, blah. So you can't trust any data that you've scanned at a distance through glass. But if it's on the glass, there's not enough distance for the refraction to matter, right? Because you're talking like mils, like you're talking about not even a millimeter, fractions of a millimeter, and frankly, registrations aren't that accurate anyway. So he's taping double-sided targets to glass windows so that you can shoot from outside, shoot from inside, and have targets to correlate the two, even though you can't open the windows. And I was like, that is a freaking awesome tip. Love that one. Want to give a shout out for Scott on that, but
that is beautiful.
Yeah, on windows. That's
yeah. This is a great segue, you know, because we want to talk about registration best practices. And so, you know, we've talked about cloud to cloud having weaknesses. Targets have weaknesses too. For instance, if you're at a high angle of incidence to the target, like if you're within, you know, 30 degrees of the target, so you know the laser shoots this way. You know, if the target is like this, you're good. But as you get to extremes, you know, 45, you know, 60 degrees, the accuracy of the scan data actually decreases, which means the accuracy of the target is going to decrease. And so, you know, targets, you don't want to use targets that are at too high of an angle, otherwise you will get bigger errors.
Yeah, I have it on the screen right here, Kelly.
Yeah, like that target. Like, don't use that target.
So yeah, I would make sure that the angle of incidence is greater than 30 degrees. Because yeah, even though it might be yeah, let's try to extract this. This is 86.
By the way, Sylvia is also famous for memorizing targets, locations in 3D space, so much so that he convinced one of our scan techs once that he could see in the dark. This is part of where the Scanpire legend came from. He just memorized what the target number was, and in a building with no lights at like midnight, he remembered that the target over there was 86. But he's looking at this. Oh, this is target 86. No, it's not. No, I mean,
this is 86, but you cannot confirm that this is, I mean, this can be off by, let's say, 4 or 5 millimeters. So I would not extract this target. Actually, probably I'm avoiding extracting 50% of the targets in model space views, because I don't want to introduce errors just because that target, that vertex, because as you can see, it places a point in space. It's going to try to match those points when it goes through the registration. If that's off by a couple of millimeters, you're already introducing a registration error. So I would just avoid extracting the targets that are at a very sharp angle of incidence.
Yeah, and similarly with the 3-point pick, that a number of them do, if you're picking 3 points on a surface, one, it is important, again, when you do those 3-point picks, in order to the same spot on 2 different scans, to do XYZ. But if you're off by, you know, a certain amount, and you've got an angle that you're picking on, you will mess up that registration. It will look close, but it is not going to be tight or accurate. And you can start to see rotational errors right away, or see things sliding past each other.
Yeah, no, it's you always need to, and like in Cyclone they call that under constrained. If your cloud to cloud constraint doesn't have enough surfaces that help you figure things out. Recap I think calls it's like what's the term for it? Strength of figure. I think they have a strength of figure metric. So they're all just different terms for saying, are there enough planes in different orientations that it found in the data to get a good match? If there aren't enough planes in enough different orientations, then the match is kind of bogus. But this kind of brings us to, hybrid registrations is what I call it. Different people call it different things, but I don't do a registration that doesn't have some number of targets and that doesn't have some kind of control. It may not be shot in by a surveyor, it may not be on state plane coordinates, but I have some kind of survey control and I have some amount of targets, and I use cloud to cloud because they all three have different error regimes, like they all have different failure points. But if you use all three, you actually, what you're creating is a system that allows you to get much greater accuracy out of the solution. Now, if you're working on really small jobs, that's overkill, right? If you're scanning a house, okay, just cloud to cloud it, right? I mean, I did hang targets when I scanned my house, but that's just because I'm anal.
And it's that big.
But probably don't need to. And then the one thing I wanted to toss out there before we jump to the last topic, which is QAQC, is loop closure. So Randy, talk a little bit about the importance of loop closure.
Yeah, and this, I mean, it goes hand in hand with the field, and I'm sure there was some discussion on it last week or last webinar, but one of the biggest things that we do on our team is we ensure that when you're registering that you're either closing a circle or some form of group that starts where you stop, right? So that you have some form of closed loop that will be able to balance that error throughout the registration. What we found is if you take a registration around a large building, you may only have like Sylvia mentioned, maybe 2 millimeters of error on every target. But if you do that 100 times, that's 200 millimeters, right? And it's not always going to miss on the same side, but ultimately that error adds up. And so what we try to do is balance and close those loops out, just so that it's all balancing between it and averaging that error out and keeps it really, really a tight registration.
Yeah, and I stole this from something else. This is true whether it's survey controls, whether it's targets, or whether it's cloud to cloud. You always want to make sure that you have groups of scans or groups of control points or groups of targets, and you want to make sure that as you're scanning, you at least sometimes you loop back and scan in the same location you scanned before. And that way, when you go through that bundle adjust process at the end, which is where it kind of averages out all the errors across all the constraints in the project, you actually have the opportunity to close that kind of accumulated error, and then it adjusts it and distributes it across every scan location. And that's how surveyors get good accuracy on large projects, but that's also how scanners get good accuracy in terms of registration.
Kelly, and the loops, don't think about them just as horizontal loops, right? You can have loops outside the building. You can have loops through the building, up the stairwell, outside on the roof, and then close it, shoot from the roof down. So you can create as many loops as you want, outside, inside, small loops, big loops. The more you have, the better.
Yep.
Exactly.
And then when it comes to QCs, like it matters how to make sure that the loop is actually in one bundle. If you're gonna break it between two bundles, it's gonna affect the end result. So make sure that whatever loops you want to use, they're within one bundle, so you let that bundle adjust based on the distributed error.
And since this is targeted at people that are relatively new, a bundle is like a really terrible technical geek term that was come up by the registration software people to basically reference a group of individual scans that are all linked together. and that they are able to distribute that error across. So, but at the same time, it's very common to have multiple bundles that are registered together, but then bundle one moves as a rigid body, right? That's one bundle that doesn't, individual scans don't adjust within it, right? The other bundle. So, you know, where you have areas of a little overlap inside to outside, usually there's an outside bundle and an inside bundle. That's a pretty common solution. And then you know, do a couple scans in exterior doorways, and then that's how you correlate the outside bundle to the inside bundle, but they don't necessarily adjust all the interior scans based on those exterior scans. On the other hand, like Sylvia said, you may have a project where you want to adjust interior scans versus exterior scans because it's a big enough project. Then you need loops that go inside to outside regularly to the building. And so this is why I was saying registration is probably the most technically complex step in the process, because to get good registrations on large projects, you really need to think three-dimensionally about basically your registration bundles, your paths that registration, your loops that you're going to close, making sure you have a mixture of targets and control and all this other stuff.
I'll add that one comment we always make is registration is the only process that can take 30 minutes or 30 days. So you don't really know how long it's going to take.
Yeah. So we don't have a lot of time yet left, and I do want to talk about QA/QC, obviously. So in terms of getting the QA/QC done on the scans, you know, Randy, why don't you kind of, what are your tips on QA/QC processes for, you know, making sure you've got good registrations?
Yeah, on our side, I think the biggest tip is that whatever the software says, it's not always going to be telling the truth, right? So especially we like I said, we work a lot in Ferrocene. I've seen registrations that come back and say 100% green targets, everything's accurate, and you open it up and you look at the scans and there's a scan that's 200 feet off out of place, right? And what happens, it may just find some form of grouping of targets that it thinks, okay, that's pretty close, we're going to use that one. You always have to visually check it. So we go in and on our team, we have a process where we colorize the scans individually so that each one is a different color, and we'll cut sections through it and really slice through each individual point cloud and visually check that every scan lines up at the end there. So the reports that come out of it are good because they tell you that, hey, we think the software thinks it's pretty close, but I will never send a point cloud out without visually inspecting it.
Yeah, so just for fun, I took a project and only did cloud constraints and recap, and then did the same thing but with targets recognized in Cyclone. And like what I've got on the screen here is you can see the errors and stuff coming out of Cyclone, and then you can see the errors coming out of recap. And the errors in recap are using these, like, you know, things that mathematicians don't even fully understand, like, you know, you've got the root mean square error of the overlap of whatever random planes it picked in the two scans that match up, and what is the percent overlap balance is their strength of figure, and then what percentage of points on those planes, and we don't know what the planes are because the algorithm doesn't ever tell you that, are within 6 millimeters, right? Not all points, just the points on the planes that it picked, right? And it's like, you can, like, this is, nobody can look at this and trust it. Like, never trust cloud-to-cloud metrics. They will completely lie to you in the face. Just bald-faced lie, right? And that's one of the advantages of having targets and being able to throw them in and use them, you know, whenever you run into errors, because targets gives you an actual vector X, Y, and Z error because you have 2 points in space and you can see how closely those 2 points in space are. And so it's just a human legible error metric. Is one of the reasons why targets for me are another QA/QC mechanism. I rarely use them now to establish a registration. Like Sylvia said, that's almost always cloud to cloud, but the targets are a QA/QC check, and then they're a tool to fix anything where the cloud to cloud fails. That's kind of how I use them. Yeah, Larry, you got anything to add?
Yeah, well, for QA/QC, I mean, this is, you know, once the project gets over a certain size, we use a second instrument and sometimes a third instrument. So we're going to hang targets on the long end of the corridors and the longest distance apart that we can get. And we're going to hit them with the total station on large projects. On smaller projects, what we carry around is a good old disto, a digital tape measure. And we'll measure from the center of a target to another center of a target and record that, write it down. And then when we get back, we're going to measure that and make sure, yes, thank you for the prop. Yeah, we're going to make sure that, not my eyes. So anyways, to make sure that those numbers are matching up. The thing is if you've got two instruments and one of them doesn't agree, you don't know which one's out of calibration or what went wrong. But if you've got three instruments, say you use a total station scanner and a disto, and two of them agree and one of them doesn't, you know which instrument is out of calibration. And if it's your scanner, then, you know, hey, it's time to send it in. That gives you some sense of, you know, something's going wrong before the client calls you up and says, hey, we're out here measuring and we don't, you know, what your scanner said isn't the same thing that what we're getting. And that is not a call that you ever want to take. So,
so your client likes to talk with marbles in their mouth, apparently.
That's right. Well, you know, we do that here sometimes.
We are down in Texas, right?
That's usually the call you get is, so, you know, I'll tell you what, that is just out in the field. We've been measuring with the tape measure, and it's just the best accurate thing. I've had that tape. My grandfather had that tape measured.
I'm taking advantage of my abilities as a moderator to mute Larry. One of my rules, of course, is always have a second pair of eyes, right? Because if you've sat at a computer for 5 days doing a registration, you are the worst person to QA/QC your own registration. So it's great to have another pair of eyes look at it, unless you're a one-man shop, in which case you're hosed. Sylvia, I want you to close us out on this, because I know, Sylvia, you get calls to help other companies with registration problems. I know you've been called in as the registration doctor on some projects. So any kind of last thoughts to add to this before we break for Q&A?
The only thing that I want to add is when you do your QC, the things that you should look for are misalignments around entryways and windows. So usually that's where you'll find things that will not align, right? Rooms might not align with the room next to it, or the interior will not align with the exterior. So always, you know, cut your horizontal slice through the point cloud and try to look for those areas, door frames, window frames. You'll see those misalignments on X and Y, and then do the same thing on the Z axis. Make sure that you have your orientation somewhat orthogonal on the screen. That will allow you to cut vertical sections through windows and doors or soffits. You'll see, because you might be able to have good results for the registration, but then on the Z axis, you'll see some big errors. Those are hard to fix. You need targets for those if the cloud to cloud doesn't do a good job. So those would be my only adds to what was said before. That's pretty much it. And Kelly,
Larry,
maybe
you can unmute yourself now, Larry. I was just having fun, just to let you know.
Kelly, or Larry, I know that you're using control a lot. I'm using control on larger jobs as well. Maybe we should explain to who's listening, how is control used? Because people might not be understanding how control is being used at the end of the project.
Yeah, and we actually have a couple questions on this. So let me do one thing real quick. Come on, show my screen. My go-to webinar panel is being a little unresponsive. It got angry at me after I muted Larry. Karma. But we actually did this for a Clear Edge webinar recently. We put together this little series of slides using a total station to establish control. And so there's also how do you establish control? What does that mean, right? So basically the concept is you go out, you set a point. Now, if you want to get on state plane coordinates or another legal coordinate system, you have to get a kind of list of points that are placed there. You have to find one of them. You have to set up on it, use that coordinate. But you can also do this just arbitrarily setting your own points. You could just decide that this first spot you set up the scanner is 0, 0, 0, and go to town, or 100, 100, 100, whatever you want. And from that point, you then shoot a second point. You usually shoot a third point. And now you have, relative to this initial position, or relative to a known state plane coordinate, I should point out, if you're doing it on state planes, you have to have 2 points at least, because you have to get that orientation from a second known point. If you're doing it arbitrarily, you can kind of do everything relative. But you get a second point, then you move the instrument to one of the 2 points you scanned, shoot back to the first point, then shoot another point. Then you move to that, you shoot back, shoot, and this is where we're closing the loop, right? We're getting back to that one of those original points we shot from the first station, and that's where we kind of have, oh gosh, now that point is 10 millimeters off. Okay, well, we know it's not 10 millimeters off. We know it's the same point, and the software kind of that does this actually will handle that distribution of error stuff for you. You can do much more complex shapes than this, of course, but that's just kind of like a simple, that's what control is. And what that gives you is basically 4 points with single measurements across the whole project, from point to point, that you can use to get that overall dimensional control, as opposed to having 13 or 14 scan positions, of which each one has some error. And like Mark's, I did it, damn it.
Knew you would.
Randy, damn it, Randy. Like Randy said earlier, we've got 13 times 2 millimeters. That's still 26 mils, right? That's over an inch of potential error. So that's not great. Take one measurement, you've got a plus or minus a couple mils. So once you have that, though, yes, Sylvie, why don't you or Larry or Randy talk about, you were going to do it, so go first, Sylvie, using those control points.
Yeah, so the way, we used to use them differently in the past, where we let the scans kind of freely move and adjust based on those control points. Now we're doing it a little bit different, where we just freeze each bundle, each group, or each registration, and then we tie those registrations to control. If the errors that are within the tolerance that we're setting, then we're good, right? We're gonna see, let's say we have 10 control points. We're gonna see that vector X, Y, and Z. And if that's somewhere around plus minus 6 millimeters, a quarter of an inch, then we're pretty good. If we see high errors, those can be because maybe we extracted the point in the wrong way. Maybe we placed the target in the wrong way. If we place the target on a pole, that introduces error. Or maybe one of the control points are bad. In that case, you disable that control point and then re-register, see if your errors are much better. So that's how we've been using it. And the way I describe it, I think of this network of points that you're just hanging registrations on it, right? And the software is going to do a best fit to those control points. So I'm curious, Larry, if you're using it differently, if you let your scans move independently relative to those control points. You're still muted. Okay.
I think you can unmute yourself now, Larry. You had it self-muted and it wouldn't let me unmute you earlier. All right.
I tried.
That's you're in the penalty box, Larry, because you didn't stop when we had this transition screen up.
No, Sylvie's nailing it. We're doing the same sort of thing. It's we're essentially creating loops, and we're trying to get the overall size of the building. We're identifying floor-to-floor levels, and through targets, and things along those lines. And I can't really add a whole lot to what he's saying.
We had somebody ask, say, all of these webinars I've attended, there's a great emphasis on errors and minimizing them. As someone who's just getting into scanning, how does one get the deliverable perfect? It seems to me that it's almost impossible. It's not almost impossible. It is impossible. Every measurement has error. Electron microscopes have error in their measurement.
Define a range.
So I remember, when we started this conversation, one of the first conferences that Kelly and I attended together, like in 2008, the best quote that still holds true is Joseph Chumley's, the thing about accuracy is you can always be more accurate. And so it's really determining the level of accuracy that you need, and then basing your work on that and not driving yourself nuts. So, that's it doesn't make sense a lot of times to try to get it to sub-millimeter accuracy and then have somebody walk out there with a sledgehammer. So it's, that's just look at the construction tolerance that you need and work towards that.
Yeah, a lot of times that's a discussion that we'll have up front with our client as well, and kind of set those boundaries. So we want to make sure that they're understanding the accuracies that they're receiving, because sometimes you may be doing 2D plan on a house, right? And the accuracy on that does not need to be sub-millimeter, but you may also be in the semiconductor fab where it does. So it's really important that you understand what the goal of the point cloud is and how accurate that needs to be. So.
And a lot of, at some point, well, we're getting in the modeling side. I was going to say, not all walls are plumb, and so where you cut that section to measure, if they pull a measure in the field and you pull a measure on the screen, if you're not measuring at the same height of the wall, and I'll be over dramatic here, the wall might be shaped like that, in reality. And so if you measure to here versus measure to here, you're going to get different measurements. And so, figuring that out sometimes it can be a little bit of a challenge.
The only thing that I would like to add to that is that understanding that range of accuracy that you need to deliver matters a lot. I worked on a project last year where we needed to deliver a LOD 400 model, like almost fabrication level model for a steel structure where all the nuts and bolts had to be modeled and documented, and holes down to 1/4 of an inch into these steel members. So understanding what is required also determines what tool you're using. So accuracy is determined by the tool. If you're using a BLK, you know what the specified accuracy for that instrument is for a certain distance from the instrument. So that's the first thing. And the second, like in terms of registration, you should always try to shoot for the most accurate registration that you can get. So that is defined by your process, your field process and your office process. But picking the right instrument will determine how accurate you can get. And then in terms of the model, that's based on how good this building was put together, because you're trying to model things as orthogonal as possible. So you're introducing error at that step. But try to shoot for the most accurate registration that you can get with an optimal level of effort. Not, because you can spend, as Randy said, 30 days, but your gain is very minimal at that point.
And with all the instruments and the software, you get what you pay for. So Recap is probably one of the least expensive, and I can put it on every single desk. But when it comes to Cyclone, there's only so much we can fund that. And same with the scanning instruments. The BLK is super cheap. It's under 20 grand, but you know, the level of accuracy beyond residential, I don't know how much I want to use it. Okay. But you go with Leica's, you know, one of their, like their P5, P50, sorry.
P50, yeah.
Yeah, and yes, it's going to give me, you know, the most accuracy, but how many of them can I purchase? And that becomes a big part of the conversation, and which projects do I really need that, you know, 3x in cost in order to get the level of accuracy. So it's but you get what you pay for in both the software and the hardware, is my opinion.
So we've got a question from somebody that seems to be doing large scale civil projects. They're worried about the Earth's curvature along control points, you know, scanning railroads or things like that. And that is an advanced topic, so I don't want to dive into it on this call for this audience. But what I would say, Peter, is that some of the more advanced tools, Cyclone, the survey module has tools for this. Collage is really, the Collage software from Topcon is designed specifically for civil work, does this really well. But they have tools to adjust for basically the curvature compensation using geoids, using all that other kind of crazy stuff to correct for the curvature of the Earth, you know, and deal with that translation across points in an effective way. You know, when you have that correction, you will end up with the little things that don't quite look like they line up at the intersections of those corrections. But that's because you are taking something Cartesian and then, you know, basically trying to map it on a curve. But those software, more advanced softwares, will handle that pretty gracefully if you're working on projects of that scale. So, you know, I would talk to the software vendor that you're using about, you know, how do you leverage geoid, how do you leverage some of those things, you know, to make those corrections and get that data exported out in a way that's useful. The other question is cleaning related. So we didn't quite hit this topic, though we've talked about it in some of the other classes, but when you're doing cloud-to-cloud registration, another big gotcha is if you're dealing with a project with tons of reflections or a lot of glass, so you have a lot of data captured through glass, that refracts or reflects data, causes error, it basically causes bad data, and the cloud-to-cloud algorithms don't know that it's bad data. So, so the question is, oh, and actually, let me jump in. Sorry, we are in the Q&A section. If anybody needs to bail, you know, we're just going to be answering questions from the audience. This is recorded. You know, when you get the link for the recording, if you need to get out of here, thank you for attending. I normally say that like at, you know, 1:02 as opposed to 1:18. My bad, got excited. But anyway, back to the question. Bye, Larry. Get out of here. I'll meet you again. Yeah, but cleaning data, you know, do you do it all the time? Do you do it some of the time? Larry, since I'm feeling guilty for muting you for so long, why don't you take a first stab at that? How do you kind of apply that rule?
As far as cleaning data goes?
Well, so cleaning data, specifically bad data before registration.
Yeah. So your mirrors, your, you know, floor-to-floor glass, it's going to give you the LSD version of, you know, the room on the other side and the other dimension that you can't quite get into. So in those situations, it may become really important to clean the data before doing the cloud-to-cloud calculations. It'll speed up the process. But then, you know, we don't do a tremendous amount of cleaning because a lot of our clients they want the model, they don't necessarily want the point cloud. But if it's going to a client where they want the point cloud, then we're likely to spend more time cleaning it up.
Yeah, and so there's kind of those two. There's the pre-processing cleaning and post-processing cleaning, and I think, you know, pre-processing cleaning you do when you're worried about the data causing registration errors and making your life miserable during registration, but you do a minimal amount. Post-processing cleaning is really more about the deliverable. You know, if you're handing the client a model and your team is the only one seeing the data, why would you clean it up since your team is are experts and they're used to ignoring, you know, transient data of a car driving through, or, you know, edge bleed data on stairwells, you know? Cool. And I share this on my screen just as an example because I love this. This is a project in Sydney. You'll notice it looks like it has a really nice hairdo on top of this building, or maybe it's an Alfred Hitchcock movie and the birds are attacking. That data is all noise from the from reflective and angled paneled ceiling tiles, and the best part of it is they're all planes.
You know, that reminds me, as I'm seeing that, if you're seeing a lot of noise above your building, that's a good indication that you need to clean your lens. That's, you know, that's another. So another form of artifacting is when you start to see stuff like that.
But up in the sky for no reason, you might have dirt on the lens that's getting a reflection or causing some weird data. Yeah. But this was a fun one. As you can imagine, this job involves a lot of cleaning.
And Kelly, if you want, I have an example prepared of, you know, what data you should clean and what data you should clean later. You know, what's pre-processing and post-processing.
Sure. We've got like literally 15 questions from the audience on this. So, you know, share your screen, sir.
All right.
While you're pulling it up, I do want to answer another quick one. We have a question in scene. How do you close a loop when registering cloud to cloud?
I have that example too, if interested.
Yeah.
Hold up. So let me jump into the scans location. So you can see we have data that's refracted through this glass that goes outside the building. We have data that goes through this glass that goes inside the building. So the surface of this interior wall, you actually can see the data that's refracted because the intensity values are slightly different. So this data that's bad data might overlap with good data. So in a lot of cases, this is just, you know, an interior window, but you might be working in a retail space where you have a lot of storefront windows. So my rule is I'm going to clean most of the data pre-registration that is going to overlap with good data. The one that goes outside the building, I'm gonna clean that at the end, because what I like about this registration tool is that you can actually work with layers. So you can create a layer, say this is exterior, so on and so forth, and you know, you can put your exterior scans on one layer, turn that off, just clean everything that goes through the window inside the building. But in this case, my preferred workflow is I'm gonna make this orthogonal, create a temporary coordinate system. That way I can align it to the top and just clean everything extremely easy. Right, so I can use a rectangular fence, grab this, and then delete everything inside. Right, if you wanna clean the data outside, you can do it as well. At this point, I'm gonna switch back to perspective, jump back into the.
Sylvia does this 3 times faster because it's all hotkeys, but he's being nice. Menu buttons for us.
So you know, that's being cleaned and ready for registration. You said this as a new control space, as a new model that's being used in the control space that you're done. So you might see that there's a door here. So I would have probably just cleaned this as well behind the glass. So that's how.
One point to make on this, because I also see people doing this mistake. So you don't have to be perfect at this, right?
No,
the goal is not to get every little bit of naughty data. The goal is to get the big chunks of it, so that you don't have large planes that are, you know, half a degree off because of refraction that cause an error in your registration. You know, if there's a couple points left behind, nobody cares. The algorithm's not going to use them. So definitely one of those things to bear in mind.
And in terms of the next question, I can show that example as well, Kelly, with the closing the loops.
Well, I think this person asked specifically in scene, which was,
Oh,
I
okay.
was gonna cue that
I
up
don't know about that.
for Randy.
Awesome. Yeah, so what we usually do when we're closing loops, so the question was regarding strictly cloud to cloud. So one of the biggest tips that I would have is one, make sure that your entire loop is in one folder. In Scene, they batch them, they call them clusters, but it's the batches that we were talking about, bushels, I forget the term that we were using, but Bundles, yeah, that's it. In Scene, they call them clusters, and so you want to make sure that all of your scans are in the same cluster. And what we'll do a lot of times is if there are some scans that are giving us a hard time, maybe the loop doesn't want to close on 2 scans, and you find them and locate them, you can add some manual targets to help tie those 2 together. Or the other option is to make a smaller cluster with just those 2 in it. So usually what I found is if they're all in one cluster and you update it and do the top view and then do a cloud to cloud registration, it's going to automatically close that loop for you and average out the error throughout the entire cloud to cloud. So that has been our process, and it's worked pretty well for us. In Scene 2, remember to lock your cloud to cloud registrations. That is anyone who's worked with it, if you have a bunch of registrations on top of each other and you don't lock them, they'll go back and re-update, and that'll take a long time and probably mess up your scan locations. So
yeah. Let's see, anything else? I do have a question about, can we get in contact with the individual presenters? So yes, all of us are on all sorts of social media channels, and of course we all have, we all work at companies with emails. So, I'm sure you can get a hold of Randy, in fact, I think you're on the Zealous website, Randy.
Yeah,
People can track you down there. Sylvia's got his website for RC Monkeys. And Larry, of course, has his website for Landmark Services. So in fact, I think we put contact information for the panelists on the Scan2BIM University page. So if you go to www.scan2bimuniversity.com, if it's not there already, it will be posted on there in the near future for this class. So if you want to reach out to individual panelists about something, by all means do so. We have one last question. Please plumb up my scanner behind me. So actually, interestingly, my scanner is plumb. What you're seeing is camera distortion from the lens on my webcam. Paul, I see you, Paul. Are there guidelines, explanations on how to interpret parameters that are calculated in C2C registrations? So I'm going to take a quick stab at this. There's usually 3 errors there are 3 metrics you're going to see. One of them is overlap, which basically talks about points that it has matched and found as having overlap. And so, just for the record, points occupy no area. So overlap itself is an approximation metric because you're assuming some percentage of points on surfaces that it's extrapolating, planar surface, it's extrapolating from the data, looking for overlap, and then re-extrapolating that back to a percentage. So there's like all sorts of weird approximations going on behind the scenes, right? But that's a really important metric because it's probably the most human understandable. High overlap, you're more likely to be able to trust the rest of the metrics. Low overlap, those are scans you should check. If you're not gonna check everything, check low overlap. The second one is going to be your strength of figure or balance and recap or align. I think it's under constrained or under aligned in Cyclone. And what that is it's basically, it looks at all the planes and it's doing a statistical analysis of basically the normal vector of all of those planes, trying to make sure that they don't all point in the same direction, or they don't all point in two directions, because you need them all pointing in three very different directions so that you can constrain in those basically 6 degrees of freedom. And so that's probably the other really important metric. The problem is, again, it's all based on what planes the algorithm in a black box decided matched between the scans. And then the last one is going to be your points, your error metric of the points on the planes that it thinks matches, how close are those points together? And that's where you'll get that like 6 millimeter or 12 millimeter or 13 millimeter or 8 millimeter or whatever error. And that's what your RMS is calculated based off of. But all of this is based on the algorithm actually correctly finding the right planes to match things up. And that's where cloud to cloud falls apart. So that's why you always have to check cloud to cloud, because the metrics are basically, they're black box. You can't trust them. They're a stab, they're a guess. And if they guess right, you get great results.
Kelly, one thing that you might notice in a lot of these registration tools, if you're using just a linear workflow, so you're registering 1 to 2, 2 to 3, 3 to 4, and then you're closing the loop, registering the last one to the first scan, you might see good overlap, good balance, and then all your errors to be 0 or 1 millimeter. That doesn't mean you have a perfect alignment. The way I would go about making sure that you have a good registration, add redundancy. We haven't talked about this, but add redundancy. So you have 1 to 2, and then register, also create a constraint between 1 and 3 if you have enough overlap. And you need to find a good balance. Don't add too many redundant constraints, because it's going to slow down the calculation every time you re-register. But add enough, because if you have a registration error, you're going to see those errors going up. Once you add redundant constraints, none of your errors will be 0. They will start to go up, because more constraints you add, things will be tighter, and you're going to be able to spot those misalignments much easier.
Yeah, absolutely. Yeah, and finding the misalignments, is one thing. Fixing them is another thing, and that's usually, most of the tools have the ability to either disable a constraint or de-weight a constraint, which lowers the impact it has. If I'm on a huge project with thousands of constraints, one of the things I like to do is sort by error and then de-weight or disable a bunch of constraints. And that will quickly kind of, normally you'd say the cream will rise to the top. In this case, the crud will rise to the top, right? Because the things where you have a really, bad error, those things will, once they're disabled, they won't be pulling everything out of whack, and their error increases. The constraints that are good, their error will decrease, because there's not that one naughty constraint pulling things out of whack. So that's a good way to quickly kind of statistically find, oh, which one of my targets or what survey control point is bad, or which of my cloud to cloud constraints is blowing me up. If you're having trouble isolating it down to which one, that's another kind of way to do it when you're dealing with a tabular result, something like Scene or something like Cyclone. And we are at, we're past 1:30, we're 1:33, so there are literally like 100 and something questions. We ain't gonna answer them all. What we will do is I will try and follow up afterwards with these questions. Any ones that we didn't answer, either through the content or afterwards, and we'll try and do a one-on-one follow-up with people. Probably post them on the Scan2BIM University group on LinkedIn. Of course, scan2bimuniversity.com has information about that on it. And look out for our next class, which will be next month. That class will be focused on post-processing stuff. So that's going to really go more into detail on cleaning out point clouds, getting rid of that transient data, getting rid of all this kind of stuff, preparing your point clouds, breaking it up, getting it ready for modeling, running it through some auto processing algorithms, all that kind of fun jazz. So that's what we'll talk about next time. Thank you all for sticking around, those of you that did. And for those that watch this later, thank you for sticking around that long listening to us, dear Lord.
You're
Any
so
last?
Get
Bye, Larry. Bye, Larry.
Bye, guys.
All right. Thank you for hosting, Kelly.
Yeah, thanks guys. That was great.
Good talking, y'all.